Now let us study Lagrange's interpolation formula. In the previous classes, we learned Newton's forward and Newton's backward interpolation methods. These methods can be used only when x values are equally spaced. That is, the intervals between consecutive x values is the same. But what happens if the x values are not equally spaced? In such cases, Newton's method cannot be applied. So instead, we use Lagrange's interpolation formula. Suppose we are given n plus 1 data points where each x values has a corresponding y values. So our objective is to estimate the value of f of x for an unknown value, x value that lies within the given data. So Lagrange's formula constructs a polynomial of degree n that passes through all the given data points. The formula shown on this slide is called the Lagrange's interpolation formula. In the upcoming examples, we will learn how to substitute the given values in this formula and estimate the unknown values step by step. So now let us solve our first example using Lagrange's interpolation formula. The problem is to find the value of f of 3 using the given data. So first let us observe the table carefully. The given x values are 0, 1, 2, 4, 5 and 6. The corresponding function value, that is f of x, are 1, 14, 15, 5, 6, 19. Our objective is to estimate the value of f of 3. So the value 3 is not present in the table. So we need to estimate it using Lagrange's interpolation formula. So now before applying the formula, we rewrite the given data using standard notation. The first x value is written as x naught. Then similarly x1 equal to 1, x2 equal to 2, x3 equal to 3, x4 equal to 5 and x5 equal to 6. Then y0 equal to 1, y1 equal to 14, y2 equal to 15, y3 equal to 5, y4 equal to 6 and y5 equal to 19. So these notations makes it easier to substitute the values into the Lagrange interpolation formula. Now all the data points are clearly identified. So we are ready to apply the formula. So now let me explain how this calculation is done using Lagrange's interpolation formula. So first you can see the general Lagrange's interpolation formula at the top of the slide. So we use this formula to estimate the value of a function at a point that lies between the given data points. In this example, we need to find the value of y when x is equal to 3. So the first step is to substitute x is equal to 3 into the Lagrange's formula. As you can see, the formula consists of 6 terms because we have 6 known data points. So each term is calculated separately. So let's look at the first term. Here I substitute x is equal to 3 into the numerator. Calculate all the differences divided by the denominator and then multiply by the corresponding y values. So similarly, I repeat the same procedure for the remaining 5 terms. That is why you can see 6 separate expressions in this equation. So after calculating each term individually, I simplify them. The simplified values are shown here as fractions. Since these fractions have different denominators, I convert them into a common denominator of 240, so that they can be added easily. So after adding all the numerator, I get 2400. So finally 2400 divided by 240 gives 10. So this example shows that by substituting the given values into Lagrange's interpolation formula and simplifying step by step, we obtain the required value, which is y of 3 equal to 10. So now let us discuss inverse Lagrange's interpolation formula for unequal intervals. So in the normal Lagrange interpolation method, we are given the x value. Our objective is to find the corresponding y value. So however, there are situations where the y values is given and we need to determine the corresponding x value. In such cases, we use inverse Lagrange's interpolation. So as mentioned here, when a set of x and y values given, we are required to find the value of x for y value that is not available in the table. So to solve this problem, we simply interchange the roles of x and y in the Lagrange interpolation formula. That means instead of taking x as the independent variable, we take y as the independent variable and x becomes the dependent variable. So by making this interchange, we obtain the inverse Lagrange's interpolation formula, which is shown at the bottom of the slide. So here the expression is written as x is equal to f of y instead of y equal to f of x. So using this formula, we can calculate the unknown x value corresponding to a given y value even when the data points are at unequal interval. So this is the basic concept behind inverse Lagrange's interpolation. In the next example, we will see how to apply this formula step by step. So in this example, we are required to find the value of x when the value of y is 85. So the given data points are shown in the table. The corresponding values of x are 2, 5, 8, 14 and y values are 94.8, 87.9, 81.3 and 68.7. So before applying the formula, I first assign the values as x0, x1, x2 and x3 and the corresponding y0, y1 and y3 as shown in the solution table. So next I write the inverse Lagrange interpolation formula. Since we are finding x for a given y value, the formula is written as x is equal to f of y. So now I substitute the given value y equal to 85 along with the corresponding x and y values into this formula. So then I calculate each term one by one and simplify the expression. So finally, by adding all the calculated terms, we obtain the required value of x corresponding to y equal to 85. So in the next slide, we will perform. So now let us substitute the given values in the inverse Lagrange's interpolation formula. Since the given value is y equal to 85, I replace y with 85 in each term of the formula. So then I substitute the corresponding values of x0, x1, x2, x3 and y0, y1, y2, y3 in their respective positions. So as you can see, the formula consists of 4 terms and each term is evaluated separately. So after simplifying the first term, the value obtained is 0.1438778. So similarly, the second term is 3.3798011. Then third and fourth term. So finally, I add all these 4 values together. The sum is 6.3038. So therefore, the value of x corresponding to y equal to 85 is 6.3038. Hence, this is the required interpolated value